There's a metal that melts in your hand. Not in a fantasy novel, not in science fiction, but in our real, physical world. A metal so soft, so delicate, that the warmth of your body is enough to turn it from a shiny silver solid into a shimmering pool of liquid. And this week on Night Scholars, we watched this idea take off. We explored space in our YouTube shorts, black holes, sound barriers, cosmic colors, but the video that captured the most attention wasn't from the stars above. It came from something far closer, hidden right here on Earth. A small silvery element with a big personality, gallium. Tonight we're taking that short, the one that reached thousands of you, and diving deeper. Because gallium isn't just a fun party trick. It's a window into chemistry, physics, materials science, and even the future of technology. So settle in, dim the lights, and let's explore the quiet, surreal world of a metal that doesn't behave like a metal at all. If you were to list the traits of metals, you might write things like hard, cold, strong, solid. Gallium says no to all of that. At room temperature, it's a perfectly normal solid, but push it just a few degrees higher, to around 29.8 degrees, and it gives up entirely. The surface softens, edges droop, and slowly, silently, it collapses into liquid. To put that in perspective, human body temperature is about 37th degree, meaning that simply holding gallium in your hand begins the transformation. It feels wrong, almost uncanny. Watching metal melt like ice under a warm breath triggers something deep in the brain. Metals don't do that, but gallium does. And that's what makes it special. Because gallium sits on the edge of the metallic world. Not quite a typical metal, not quite something else. It resists the categories we try to put it in, which makes it perfect for scientists and perfect for storytelling. Gallium was discovered in 1875 by a French chemist named Paul-Émile Lecoq de Bois-Baudran. He didn't find it in a mine or a chunk of ore. He found it in light. Using a spectroscope, a tool that splits light into colors, he observed a set of bright blue lines he had never seen before. It meant that inside his sample was an undiscovered element. Imagine it, a hidden metal, revealed not by touch or sight but by the colors it cast when heated, like a secret signature written in light. And in a poetic twist, the element he discovered would become famous for transforming with just a touch. To understand why gallium melts so easily, we need to look at atomic structure. Most metals pack their atoms tightly, forming a strong crystalline lattice. Gallium forms a loose, awkward structure. Its atoms don't fit together very well, so they fall apart with just a little heat. But here's the fascinating part. Gallium also expands when it freezes, just like water turning into ice. Almost all metals shrink as they solidify. Gallium does the opposite. This has real consequences. Pour liquid gallium into a sealed container and let it freeze. The expanding metal can split the container open. Scientists love gallium because it breaks the rules. It challenges assumptions. It forces us to rethink what metal really means. If you've ever held gallium, you know it doesn't feel like normal metal. It's cool at first, smooth and dense. Then it softens. It gives way. And suddenly it's running like mercury, but safe, non-toxic, and completely touchable. Watching it change state feels like watching time-lapse footage, even though it's happening right in front of you. It's as if your hand is casting a spell. Its surface reflects light like a mirror, and when it pools in your palm, it looks like a drop of liquid chrome. People describe the experience as surreal, satisfying, almost magical, slightly unsettling. It's a reminder that the materials around us, steel, aluminum, copper, behave the way they do because of microscopic structures we can't see. Change those structures even slightly, and the world becomes stranger than you expect. Gallium is not just a fun curiosity. It's quietly powering the modern world. 1. Electronics. Gallium is a key ingredient in gallium arsenide and gallium nitride, materials used in high-speed electronics, LED lights, laser diodes, smartphone components, solar panels. Yes, pieces of gallium are inside the phone you're using right now. Medical imaging gallium compounds allow doctors to track inflammation, infection, and cancer growth. In a sense, gallium lets us see inside the body. Heat transfer and cooling. Because gallium melts so easily but doesn't boil until 2200 C, it's perfect for experimental cooling systems in computers and reactors. Imagine a metal that melts like chocolate but refuses to evaporate even when red hot. That's gallium. 4. Low-melting alloys. Gallium is used to create alloys that melt under heat, pressure, or electrical signals. Perfect for automatic fire sprinklers, precision fuses, robotics, experimental soft machines, which leads us directly into the next chapter. This is where gallium becomes futuristic. Scientists have been experimenting with liquid metal machines, tiny robotic structures made from gallium alloys that can change shape, split, merge, and move under magnetic fields. Videos from research labs show gallium-based robots squeezing through bars, forming new shapes, jumping, when exposed to magnetic pulses reforming after being cut apart. It's science fiction slowly becoming science fact. The idea is simple. If you can control the shape of liquid metal, you can create machines that adapt to their environment. Soft robotics is one of the fastest-growing fields in engineering, and gallium sits at the center of it. This is something that doesn't get talked about in textbooks. Gallium is one of the rare metals that lets you interact with it directly. You can hold it, feel it, watch it change because of you. There's a psychological impact to that. It turns the laws of physics into something tactile and personal. It's not dangerous like mercury. It doesn't burn like sodium. It doesn't react explosively. It simply melts, gently, obediently, as if acknowledging your presence. This makes it a favorite in classrooms and science demonstrations. A way to bring young minds into the world of chemistry without fear. A moment that says science isn't abstract. It's here in your hand. As humanity pushes into new technologies, quantum computing, advanced cooling systems, flexible electronics, gallium is becoming more important. It may not be rare, but it is precious in another way. It represents the future of materials, subtle, adaptable, smart. A future where metals are not simply tools, but responsive, dynamic partners in innovation. And just like our video short that unexpectedly took off, sometimes the small, overlooked things hold the biggest potential. So we return to the simple image. A drop of gallium melting in your palm. Silent, silver, alive in a way metal shouldn't be. From its discovery in the colors of light, to its role in the electronics powering modern life, to its philosophical reminder that strength can come from softness, gallium is more than a curiosity. It is a symbol, a scientific wonder, a technological tool, and a quiet piece of magic hidden in the everyday world. And that's why your short resonated. Not because gallium is flashy or explosive, but because it's strange and gentle and deeply human. A metal that melts in your hand and stays in your mind long after.